Welcome everybody to our Engage with NASA resources and activities, connecting space rock content and more with learning environments. My name is Paige Graff, and I'll be your lead speaker tonight. But monitoring the chat and the Q&A is Kim Willis and Suzanne Foxworth. We make up part of our science engagement team, and we have experience in classroom environments, we have experience in informal environments, and we work with our subject matter experts to be able to create the types of resources that you're going to see with us today. Now, perhaps you're thinking, oh, I think I've seen this activity before. Perhaps you have, but over the last couple of months, we have revamped, revitalized, and even made enhancements to some of our activities. So hopefully, if you've seen some of this before, you're going to see some new ways of approaching these activities that we have for you today. So with that, all of these aspects that you see on the screen, and I'm not sure if you can see my mouse, but I think you might be able to, we're going to share each and every one of these things and a little more, time permitting, during tonight's webinar. And we're going to start by focusing on some material related to NASA's Apollo moon rocks. And to make sure that we're all kind of on the same page with some consistent background knowledge, I'm going to play a short video about how NASA got samples from the moon.
Tranquility Base here. The Eagle has landed. Oh man, look at that rock out there. Absolutely incredible.
So now we all have a common knowledge about how NASA got samples from the moon. And as you can see here in our laboratory, only certain people can work in this lab because there's certain types of material and dress that you have to wear to get into the lab. So not everyone gets a chance to handle moon rocks. But one of our resources that I'm going to share, Astromaterials 3D, this website gives an opportunity for all, no matter where you are, to be able to interact with NASA's moon rocks and more. Now, right when you get to this website, you can immediately start interacting with a sample on the screen, but then you can sort of choose your own adventure. Do you want to explore our Antarctic meteorites from the moon, Mars, Vesta, or other parts of our solar system? Or do you want to be able to focus in on those moon rocks from any of the 6 missions where we sent humans to the surface of the moon? Now, let's say I like Apollo 16, and you want to explore the samples there. You might find a sample of interest, and you might decide, I want to explore this sample further. Well, what does it mean to explore further? Well, again, on this page, you can interact with that sample, looking at all faces of it. Or you can open our Explorer tool, where this little eyeball on the right will open up a set of tools where you can look at the sample in different lighting conditions, perhaps, or even look at the sample in 3D. And I didn't ask you to bring red, blue glasses, but if you have them, you want to use them if you're exploring Astromaterials 3D in 3D, because it's like they're jumping out of the screen right into your lap. So that's a lot of fun. But thanks to X-ray computed tomography, you can actually slice in and see the interior of a sample. And you might note things that are of particular interest. Well, if you find something that's interesting, you can drop a pin, you can write in a description, and then you can even save and share that link of your aspects of interest with one another, with a family member, with another learner, with a coworker, or students in a classroom can share it with the teacher. Now, as every rock has a story, there's also a bit of a story about the sample, so you can learn more detail about that sample And there's a whole lot of other detail that's available as well. Now, this is a really, really powerful way to be able to explore like never before. And honestly, this is an unprecedented way to enable learners anywhere across the world to interact with these lunar samples or even meteorites. We'll look at that later. But the other thing you can do from this website is, if it works for you, you can download and print your own 3D model. And so there are all the files there that you could ever want, but those that you want to use to be able to download, make your own 3D print. And then once you have a print, you can even add a little bit of coloration here and there to make that sample look even more like the real thing. And so that's a great option for folks to be able to utilize as well. Now, Astromaterials 3D is something that, again, it's an unprecedented way to be able to explore more. And we really want to hear from folks out there, like all of you, how you may use or how you may be using Astromaterials 3D. So this QR code is actually just takes you to this link. And what you'll find on this link is a place where you can click Submit Your Publication. Now, does that mean you have to be publishing an article or something like that? Not at all. Submit your publication means publicize to us what and how you're utilizing Astromaterials 3D with your learners. And perhaps we can add that to our website to showcase how you might be incorporating it into an activity, how you might be incorporating it into an art class, or whatever the case may be. We want to hear from you. Now, in terms of Astromaterials 3D, for some learners, they might need a little bit of background knowledge to help them get the most out of Astromaterials 3D. There's a lot of content there that if learners have some background and they're prepared to sort of ingest more information, it can be really useful to have that background. So one way we've provided in terms of enabling learners to be able to build some background knowledge is classifying moon rocks. Let me play a brief intro.
That's one small step for man, one giant leap for mankind.
Now, the beauty of that little intro is that it allows learners to realize, wow, even though we got these samples 50 years ago, we are still getting a fresh look and revealing secrets of our solar system even still today. Now, the other thing with the interactive is it does play that little video I shared with you earlier on how we got samples from the moon. But also we have one of our folks from the lab, Charisse here, that helps step learners through some additional background knowledge about the moon, about how the moon might have formed, and also about the samples and how classifying them provides insight into how and when these rocks formed on the moon. So in this interactive, we talk about anorthosites, representative of the original lunar crust. And we also give you some characteristics so you know if you're looking at an anorthosite, how do you know? Then we have basalts, and there's information about how they formed on the surface of the moon. And then there's characteristics to help a learner identify how do you know if you're looking at a basalt. Same thing with impact breccias. These rocks formed by impact events, some background, as well as the characteristics you would look for to be able to find or identify if you're looking at an impact breccia. Now, within the interactive, you're asked the question of how would you classify this? You can take a look at a 360-degree view of the sample. If you get it wrong, we give you some key characteristics to help you get it correct. And if you do, once you get it correct, we reinforce with some supporting evidence, an important part of science, and we give you options to learn more. Learn more about the Apollo 17 mission, learn some fun facts like here's a view of Shorty Crater and Harrison Schmitt where he discovered this orange soil. And there's even a view of from the Lunar Reconnaissance Orbiter of what the surface of the moon looks like even today with the tracks of our crew that traverse the surface of the moon. So this building of background knowledge and options to be able to explore more is a really great way to be able to help learners deepen their knowledge and perhaps better prepare them to focus on Astromaterials 3D. Now, in your learning environments, whether you're in a classroom, whether you're in a museum environment, whether you're doing an outreach type of session, perhaps you even want to utilize our printable cards that have the same general information, but in printed cards so that you can have learners be able to sort cards, decide whether they're an impact, retro, basalt, or otherwise. But it always is so important to reinforce to learners that really you should be able to justify your answers. And the more they can get used to providing evidence to justify their thoughts, that's really important part of science. So you could start with the printable cards and then encourage folks to do the online interactive or vice versa. So that's classifying moon rocks in an online interactive or a hands-on activity option. Now, let's say that, you like moon rocks, but you're really interested in meteorites. Well, another activity we have is our Antarctic Meteorite Discovery Board. And this is a puzzle-like picture matching activity designed to introduce learners to meteorites and NASA's Antarctic Meteorite Collection. Now, what you'll notice here is there's a bit of what I'll call a rosette that includes hexagons of varying colors. And each of those colors represents a different theme. The puzzle-like picture matching pieces are off to the side. And these pieces will fit into one of the quadrants of one of these hexagons. So hopefully that made a little bit of sense. Let's delve in a little deeper. Now, in a classroom setting, one thing I would recommend, and this is an option, is to help your learners get focused first. So this set of handouts here is designed to help prepare learners, get them focused, help them learn some fun facts, and help them make predictions about what kind of picture do they think is going to represent the content within the particular hexagon. So this is all about kind of getting them ready for what they might be asked to do, which is finding picture matches. Well, here's an example of one of those tables kind of blown up with the hexagon theme meteorite features shown here. So you can see in the center of the hexagon, that's the hexagon theme. In this case, meteorite features. Off to the upper portions of each of these hexagons, we have quadrant focuses or foci, what is really the main idea of an individual quad. And then within a particular quad, there's additional details so a learner can get a sense of, well, what are these things? So in the handout, we ask folks to highlight or circle or put a box around some key information and then think about what they think the picture will look like. In this case, my sample answer is a picture showing a meteorite, since we're talking about meteorite features, with these round objects, which are chondrules somewhat visible. So that would be sort of a sample answer. So once learners have gone through the Get Focused handout and they have a sense of what information is going to be covered within these different hexagons and the themes, then the next step is to have them start placing pictures on the hexagons. So I have some sample pictures here, and here's where I'm going to ask for a little bit of your help in the chat. In the chat, I would like for you to tell me which picture piece, 1 through 6, best matches the top left quad content. And if you'll put your answers in the chat, I'll see if anyone is kind of giving me any thoughts, giving me any answers, and perhaps hopefully if this is making sense. So we'll see if we get any answers in the chat. Which picture piece, 1 through 6, best matches? So I'm getting some answers in there. I have a possible 5, a possible 3, a possible 5, a possible 6. Let's see if we can get some consensus. You may think about why you think a particular piece is the piece of choice. So I have a lot of 5s. I have some 6s. The diagram's hard to read, and that could be very, very true. So I'm seeing a large majority of 5s, in some cases 6. Now, one thing to be aware of is there's always going to be a key matching word. Like, look at the quad focus, chondrules. If we look at any of these pictures, we do see in picture number 5 the word chondrule. So that's one of the hints that probably tells us, you know what? I see a round object. I see a labeled chondrule. This is my matching picture puzzle piece. Now, you might have seen in picture piece number 6 the word chondrites, which was written on that in the background quad details. But you need to think about, does the orientation of the piece fit, as well as does the content match? And chondrules, yes, are shown in number 6, but there's a more highlighted view of that chondrule in picture number 5. So in this activity, we only did one quad with a couple of pieces to look at. I want you to think about your learners to be able to think about how to set them up for success. Let's think about this for a moment. We have 6 hexagon themes, the red, orange, yellow, green, blah, blah, blah. Each of those hexagon themes has 4 pieces that will be connected into that. So that's 24 total pieces. If you were to hand a group of 3rd graders, here's your rosette, here's 24 pieces, their minds might go like, I don't know how to deal with this. So a couple of options to think about. If in your classroom environment you did the Get Focused handout, your learners are going to be ready for you to say, okay, here's all 24 pieces, have at it. And hopefully they can have some success. If you have younger learners, you might think about, well, even if I had them do the Get Focused handout, maybe I want to have pieces for the left side of these hexagons be on the left side, and the pieces that belong on the right side of the hexagon rosette on the right side, so that they have a fewer number of choices to deal with as they're completing the puzzle. You might also think about other strategies that might work for you. But in the end, having this really nice pictorial view of our Antarctic Meteorite Discovery Board, you have a really neat sort of way to be able to think about, oh, where do these, or what are the origins of these? Oh, for asteroids and Vesta and the moon and Mars. And so you're really almost having a summary view of some of the content that we're trying to help learners digest with the Antarctic Meteorite Discovery Board. So it's a really neat way to kind of have a little bit of a challenge of a puzzle-like activity and building some knowledge with learners about meteorites as well. Now, one thing about meteorites that's kind of cool, or at least about this activity, is we have created one way you might assess your learner knowledge, and that is these little chatter boxes. Now, some of you might remember calling these cootie catchers. This day and age, I like calling them chatter boxes because they're kind of like little things that are chattering and talking to you. But whatever you think of them as, for our examples here, we call these meteorite chatter boxes. And you can have your learners assign a point value into the center circle here. So they have a random number of points, 1 through 8, that someone would earn if they ask and answer a question correctly. So we have chatter boxes with pre-written questions, and then your learners could write in their answers. And we also have a chatter box where the learners can write in their own question as well as write in their own answer as well. Now, how might they remember some of the content? Well, they can refer back to the Meteorite Discovery Board or even the Get Focused handout, which will give them some information to be able to use as they work on their chatterboxes. So this is just one way to be able to assess some knowledge. We also have some question cards that you can ask your learners as well to assess their knowledge that way. But back to the Meteorite Discovery Board, one thing, again, as I may have mentioned earlier, is by building some background knowledge, we're arming our learners with some enhanced knowledge that will perhaps prepare them more to explore Astromaterials 3D and the meteorite aspect. So it's all about building background knowledge to enable those learners to get the most out of whatever resource that they may be using. Now, the other neat thing is you might see some people in some of the pictures and in some of the laboratories. And one really important part that we want to make sure that learners of all ages realize is that, our meteorites in our collection come from the Antarctic Search for Meteorites, or ANSMET expeditions, where folks are sent out to Antarctica to search for meteorites. But these folks or individuals that go to Antarctica, they are from many different backgrounds. And they're men, they're women, they're young, they're older, they're from all different walks of life, so to speak. Many of them are involved in research, but we want to help our learners realize that, hey, they too, you too, can be one of these folks that can be involved, whether it's searching for meteorites or even studying meteorites. So we've also created another resource to highlight the diversity of subject matter experts that work with NASA science or meteorites or other aspects related to science. And these career hexagons can be a really powerful thing to use with learners. Now, I'll break down a little bit of how these are oriented. There's these little foldable tabs about an individual's background, what they do, their hobbies and interests, their inspiration, challenges they've had to overcome, and why they love their work. And then if you open up those tabs, you can see in this example of Jordan Marie, she's from Connecticut. She's got hobbies like hiking, furniture, exploring Houston's great food. She's a first-generation college student who didn't have very many role models, and now she actively works as one of them in her community. And the best part, perhaps, is also seeing some of these images showcasing, in this case, Jordan Marie in some of the work that she does. Our goal with these is to enable learners out there to perhaps see themselves in this person or in what inspired this person, or seeing commonalities with their hobbies and feeling like, wow, I could do that too. Now, on the back of these hexagons, we go into a little bit more depth about the background, the college degrees the individual may have obtained, and we always have a piece of advice from that subject matter expert as well. So these are really powerful. But now sometimes your learners may meet, or you might have in a classroom, a subject matter expert talk to your students. Well, in that case, maybe you want to have them make their own career hexagon about a visiting subject matter expert. Or maybe you want your learners to think about their futures, where they can put in what their career aspiration is, whether that's a scientist, an engineer, an astronaut, a veterinarian, an artist, whatever the case may be. If they start to think about their future career paths and steps that will help them pursue their future career, then perhaps they're setting up some goals and putting things in writing that can always be changed, but at least it gets that ball rolling for them. So these career-related hexagons are a really powerful resource in many different ways. All right, moving on to our next activity/resource, the Meteorite Map Challenge. Now, we've had a previous version of this, and we've updated it to kind of look the way this does now. This really, the colors and pictures and a little bit of words, because we always try to get our learners to do a little bit of reading, makes sometimes a resource a little bit more inviting to learners. So what you'll notice is in this, we're going to find meteorite-related locations around the world and learn fun facts. So we've got a map in the center of the page. We've got pictures with questions and hints under them. And there are some instructions and tidbits of information as well. Well, the way this works is that step one would be to set up your map with your numbers in place on the map, 1 through 8. And then you want to have learners read questions and hints and match to a map number. So for example, my first question from this lower left-hand portion, I've blown this up so that hopefully you can see it. Where is NASA Johnson's Antarctic Meteorite Lab? A hint, a city along the Texas Gulf Coast of North America. I check out my map. I can identify where North America is, the Texas Gulf Coast. Well, I think that's going to be item number 3. And then learners would move their map number to the matching challenge board picture or question. Well, let's see if we can test your knowledge. Play along with me if you would in the chat. Which location on the map, 1 through 8, matches this card? And the question is, in case you can't read it, where have teams of explorers searched for meteorites since 1976? The hint is Earth's southernmost continent. So let's see if we have answers in the chat, and I'm seeing numbers as well as some of you are even answering the question, which is great. And you're absolutely correct. 7 is the correct response. Let's do a harder one maybe. How about this one? Play along with me in the chat if you would, please. Which location on the map, 1 through 8, matches this card? Where was the largest witnessed meteorite fall of this century located? And the hint is a city in a country that spans across Europe and Asia. So again, we have a map legend if folks need a little bit of help, or if a learner, so we're also teaching geography here. And so we have some thoughts in the chat, some question marks, but the large majority of you, I so appreciate you playing along. The large majority of you are saying 8, and you're absolutely correct. That's where the largest witnessed meteorite fall of the century is located. So one more. How about which number matches this one? And again, put your answers in the chat. Where were the ancient Allende carbonaceous meteorites found in 1969? And the hint is a town south of the USA-Mexico border in North America. So look at the map, see if you can find or identify the location there, and see where a town south of the USA-Mexico border in North America is. And the large majority of you are coming up with the number 1, which is absolutely correct. Now, if you were thinking, oh, maybe it's 6 north of the border, if you put in a number, you can self-correct at a later time. But most of you out there in the chat, and again, thank you for playing along, you got it spot on. So step 1 is just identifying the locations, and you'll notice there's pieces of information in both the question as well as the hint, like these meteorites were found in 1969, or, there's a little bit of tidbits of information there. But step 1 is about making those map matches. As you continue on, step 2, or I'll call it a bonus challenge A. And this is, I think, especially useful in a classroom setting, because I know as a former classroom teacher, getting your students to read is like sometimes pulling teeth. And the more we can encourage them to read with short little cards with a little bit of information so that they're not overly intimidated, the better we can help them perhaps to want to read a little bit. So in this bonus challenge A, it's all about placing each fun fact card under or next to the map images or the matching images around the map. So in this case, this lab curated Antarctic search for meteorite samples since 1978, blah, blah, blah. So I'm like, oh, yeah, that's that lab at the NASA Johnson Space Center. I'll put my card there. And so this becomes a fun way to learn some fun facts. So let's test your knowledge and get you to learn some fun facts. So here's our card and our question, and you tell me in the chat, is it A or B, the fun fact card that matches this question? And the question, in case you can't read it, is where was the largest witnessed meteorite fall of this century located? Hint, a city and a country that spans across Europe and Asia. So does A fit the bill or B fit the bill for this fun fact card? And I'm looking in the chat and I'm seeing some answers come in. And again, thank you for playing along with me. And again, you doing a little bit of reading, maybe you enhanced a little bit of your knowledge as well. But B is the absolute correct answer. Let's do another one just for fun. Which fun fact goes along with this one? Where were the ancient Allende carbonaceous meteorites found in 1969? Again, a town south of the USA-Mexico border in North America. Is the answer here A or B? And we'll see what comes in, and hopefully I'll be able to distinguish between the last question and this one. So where were they found? Which fun fact goes with it? And I'm seeing mostly the same answer here. And in this case, that answer, or the common answer, and someone self-corrected, that answer absolutely is B. So again, a little bit of information helping even learners see, oh, this Allende carbonaceous chondrite is estimated to be 4.567 billion years old. So that's self-correcting, and that little bit of learning and a little bit of reading can go a long way. Awesome. So that's bonus challenge A, and that can be used probably within a classroom environment where you really want to encourage those students to do some reading. But let's say you're in an outreach event, you're at a museum, you got a table set up, you've got the map, and you've got these stack of cards now looking at bonus challenge B. Folks have perhaps put their numbers in the map locations, and now you want to test, can they answer the questions with location names? So in this case, where is NASA Johnson's Antarctic Meteorite Lab located? Somebody might say Houston, or Texas, or Houston, Texas. Any or all of those variations are correct. But if you're doing challenge B, the learners are actually given a card, and it's a front and back card, so that they can, like, once they have their map location in their area, they can, like, think about the answer and then turn over the card and see, I have my correct map location. I do have the correct answer, Houston, Texas. And oh, by the way, if you didn't do the fun facts with them, here are those same fun facts, but hopefully they'll read them. But then we also have a little QR code and a description of what that QR code is going to take you to in case learners want to be able to explore more. So let's do a couple of these. So we did this one. Oh yeah, so once they have the card, they place that card right underneath, again, the answer, and to be able to reinforce that they got the correct answer or to help them self-correct. So how about this one? I know I keep coming back to this because this is just an interesting question. And we'll see if you can answer with a location name in the chat. And I'll look at the chat to see what comes available, or what answers you put in. So where was the largest witnessed meteorite fall of this century located? And again, that hint is there, a city and a country that spans across Europe and Asia. And again, any part or possible answer, there's lots of choices. So I've got Russia in there. I have Chelyabinsk. I have Chelyabinsk, Russia. I have Russia and Chelyabinsk in Russia. So depending again on the knowledge or the ability to spell some names correctly, You might have people, and if they're orally saying, oh, I think that was Russia or Chelyabinsk, Russia, they can check themselves. Absolutely correct. Chelyabinsk, Russia. And this happened in 2013. Now, again, we have that little fun fact, and then the QR code, which would take you to a video of an archived webinar where we recommend watching about 3 minutes to learn more. I think this is too good to not share. So if I were to scan this QR code and go to this video, let's see what the video shows.
Okay, this has no sound, but I wanted to give you an idea of what happened and why we care about planetary defense. Back in 2013, over Chelyabinsk, Russia, a significant meteor came in about 20 meters across, a bit bigger than a school bus size, came in at high speed and exploded over Russia. And it released a lot of energy, 20 to 30 times more energy than the atomic bombs that were dropped in World War II. You can see the fireball going across the sky there from video cameras. Lots and lots of damage over the area, lots of windows broken, and several people, about 1,600 people were hurt actually. 100 people were hospitalized, but 1,600 people were hurt. So this was a big, big day for us. This was something that caught us by surprise and certainly got our attention.
И сгорел там, да? Ну.
That's what happened. They were looking up at the sky and they saw the contrail, and then all of a sudden that blast, that shockwave hit them, right? So they're pretty frightened. So here's some more videos. Again, no sound on these, but you can see the shockwave hits and all the windows blow out, or a lot of the windows blow out. So these are cameras that are just set up, and this was wintertime in Russia, so a little bit cold. So when they have all the windows blow up, that's a problem. Watch what happens here. There's this, what happens to the ceiling and these people. Those glass ceilings cave in this warehouse. And then watch what happens here. They see the flash and they're looking up at the sky at that big contrail, and all of a sudden the shockwave hits and blows people back away from the windows. So again, they didn't know what was going on. They didn't realize it was an asteroid impact. They thought there was something else. Watch what happens to this door. It blows out, or blows in, I should say, from the shockwave hitting. So kind of a very, very scary. Again, watch what happens to these people. They're starting their morning. They don't know about the asteroid impact. They're near the window, and they think, they're not sure what's going on, but something bad's happening, so they run away. So these are all these type of things that happened. Again, you can see this in a classroom. Children getting ready in the morning, and the windows blow in, and lots of explosions.
One thing I want to mention is think again about your learners. You don't want to scare them. Some of that, if you perhaps noticed, I said, here comes a loud sound when they were actually hearing that loud explosion, that airburst explosion. So prep your students or learners as necessary and make sure that they realize that this is not a common occurrence, but it was a wake-up call about planetary defense. And so, but again, what we don't want to do is scare our learners, but we want to help them realize that we can learn from things, and we actually get samples. In this case, there are samples from Chelyabinsk that can then be studied to help us better understand that particular sample that ended up landing in Chelyabinsk, Russia. So one more question here. I just thought that video was too cool to not at least play a portion of it. One last one for you to put answers in the chat. Where were the ancient Allende carbonaceous meteorites found in 1969? And actually, as I look at time, I'll just give you the answer here. Pueblito de Allende in Chihuahua, Mexico. And again, you can see the number. There's that fun fact. And what's interesting and why I keep coming back to this particular sample is because it's a carbonaceous chondrite, and carbonaceous chondrites are some of the most primitive materials from our early solar system. And again, pieces of this are estimated to be 4.567 billion years old. Now, oftentimes with carbonaceous chondrites, including Allende, we don't know the parent body, the origin. Where did this come from that ended up landing in Mexico in 1969? But what we can say is we can explore carbonaceous asteroids and perhaps learn more about carbonaceous chondrites. And that's exactly what we did with the OSIRIS-REx mission. So the OSIRIS-REx mission, rather than me tell you about the OSIRIS-REx mission, I'm going to play another short video so that you can get some context about to Bennu and back.
OSIRIS-REx is NASA's first asteroid sample return mission. It launched in September 2016 on a journey to explore a near-Earth asteroid called Bennu. After arriving in 2018, OSIRIS-REx spent nearly 2 years orbiting Bennu, mapping and studying its rugged terrain before carrying out its primary science objective. On October 20th, 2020, the spacecraft ventured to a small crater in the asteroid's northern hemisphere. It dodged jagged rocks and towering boulders and plunged its arm into the loose surface, excavating 6 tons of debris while collecting about 250 grams of material. OSIRIS-REx stowed its bounty and closed its sample return capsule. It bid farewell to Bennu in May 2021, embarking on a 1.2 billion-mile cruise back to Earth. Now, 2 years and 4 months after leaving Bennu, OSIRIS-REx is closing in on the place where its journey began. On September 24th, the spacecraft will approach to nearly 63,000 miles from Earth. It will power up and release its sample return capsule at 4:42 a.m. Mountain Time. The capsule must be jettisoned within a narrow time frame and at just the right angle to hit its target, an area of roughly 250 square miles in Utah's West Desert. Once the capsule is away, OSIRIS-REx will fire its thrusters to avoid colliding with Earth. At 8:42 a.m., the capsule will streak into the atmosphere at a blistering 27,000 miles per hour. It will race across the western U.S. and begin to glow with heat, allowing infrared trackers on the ground to chart its progress. As it pushes deeper into the atmosphere, the capsule will rapidly decelerate, subjecting the Bennu samples to a punishing 32 Gs. About 2 minutes after entry, it will slow to Mach 1.4 and deploy its drogue parachute, stabilizing its descent. The capsule will enter special use airspace at 8:46 a.m., almost 10 miles above the Department of Defense Utah Test and Training Range. Radar stations will lock on and track it to within 30 feet of its landing site. At 8:50 a.m., the capsule will extract and deploy its main parachute 1 mile above the ground. It will make its final descent at a leisurely 11 miles per hour, like a marathon runner savoring a victory lap, before touching down in the desert soil at 8:55. After ground teams retrieve the capsule, the Bennu samples will be taken to NASA's Johnson Space Center in Houston, Texas. The sample canister will be opened in the Astromaterials Acquisition and Curation Facility, and the samples will be curated, distributed, and studied for decades to come. Having delivered its cargo, the OSIRIS-REx spacecraft will depart Earth, but its journey will not quite be finished. In a daring encore, the renamed OSIRIS-APEX will enter an elliptical orbit of the Sun, repeatedly passing within the orbit of Venus and pushing the limits of its thermal design. Beginning in 2029, it will chase down and investigate Apophis, a 1,200-foot stony asteroid destined to make an exceptionally close flyby of Earth. After 13 years in deep space, at the start of a new decade, alone on a new world, the journey will continue.
So that video, while yes, we landed successfully, that buildup and knowledge of visiting asteroid Bennu, which is a carbonaceous asteroid, while that OSIRIS-REx return capsule successfully delivered sample from asteroid Bennu to Earth. There it is on the left. in the Utah desert. There's the temporary curation facility that was put together in preparation to receive that sample. But OSIRIS-REx sample from asteroid Bennu is now in its new home at NASA Johnson Space Center. And that's in the lab where we work at the Johnson Space Center. So it's interesting to think about the OSIRIS-REx sample from this carbonaceous asteroid Bennu will enable research for current and future scientists, including students and learners that you may interact with today. And so NASA always holds back a certain portion of a sample to be able to be utilized by the next generation, as well as with new and improved technologies that can be used to study the sample. So this is a great way, again, to think about the excitement of space exploration. And in this case, the reward, in a sense, is the sample that researchers get to work with. Now, just like with our Apollo Lunar Lab, you just can't walk into the OSIRIS-REx lab. You have to have specialized clothing to wear because you want to be able to keep the environment as clean as possible. So since folks on the outside can't go into the lab, we created an activity or resource called Exploring NASA Laboratories. And in this case, we, in a sense, bring you to the lab and help build some content, knowledge, and background about the lab, about the sample, and again, have you do a little bit of a picture match. So looking at these labs that we have the OSIRIS-REx Curation Laboratory, but we also have the Antarctic Meteorite Curation Lab, the Lunar Curation Lab, Hayabusa 2 samples collected from asteroid Ryugu, and even Genesis samples collected from the sun. And in each of these activities or each of these labs, there are pictures and people and clean room classification details associated with them. Now, you might be thinking, well, I don't know what a class 100 or a class 1000 or a class 10,000 clean room environment is, but looking at these little squares and the pictures and the amount of particles within them perhaps will hopefully provide some insight into really clean versus moderately clean, but still clean. So the way this activity works is a learner would read some information. Okay, I'm looking at the OSIRIS-REx Curation Lab, and I'm going to find the spacecraft image that was used with an asteroid, used to collect sample from an asteroid, and it had a 11-foot, 3.35 meter arm. So, oh, I think this looks like this, and they placed the picture into that section. Collecting samples, they might notice, oh yeah, this one after doing some reading, and I'll briefly go through this. And then the curated sample, loose surface material and small rock fragments. And then, the clean room clothing. Well, yeah, they got to wear a lot of gear to be able to safely work in that lab, keep the sample safe. And then they can place the clean room environment into its spot, as well as the lab personnel. So we again like to do this on magnetic boards and print the pieces on magnetic paper or adhere a magnet to them so learners can kind of stick these pieces into their appropriate location. And even with the persons in the lab, there's a couple of different people that they can put in each lab. So it's a neat way to be able to enable folks to learn about some of the labs where we actually curate samples, or even think about other labs or facilities that perhaps they have visited, perhaps they have learned about, or perhaps they heard about or researched, and learners can sketch their own lab-like environment or analog environment, and then write in their own pieces of information and draw out their own picture pieces that would correspond to a particular lab. So that's like an extension of that if they have additional labs that they want to be able to explore and share with others. Now, again, in a classroom environment, one thing that I like to think about doing is preparing my learners to learn some things first before they're just matching pictures. Because if they're just matching pictures, they may not retain some knowledge. So just like with the Get Focused handout with the Meteorite Discovery Board, we have the same set of resources for exploring the NASA laboratories so they can learn some knowledge, think about what the picture may look like, and hopefully gain some knowledge that they can then even be able to utilize in a chatterbox if they want to make their own cootie catcher or chatterbox using information from the Exploring NASA Laboratories activities. So that's Exploring NASA Labs. Now, as I look at my time, I have a few minutes and I want to share another resource with you. We'll come back and I'll look at some of the questions that might have come in, but there's one other resource that I want to at least share so that you have an awareness in case it's of interest to you. And then we'll come back to this. And that is, we have another set of interactives called Where in the World, where we focus in on looking at images taken by astronauts using handheld cameras from the International Space Station. And in this online interactive, there's an intro that gives you some background about the International Space Station and the images taken. But within this expedition, learners are asked to look at an image and determine where in the world is this? So on the online interactives, there's 15 photographs in each one to explore. You can keep track of your progress, and then you can earn a badge, just like with the Lunar Lab classifying moon rocks as well. So here's a picture. If you need a hint to make an educated guess as to where in the world this is, the hints are great. And then you can discover, I think this is Mauna Kea, and sure enough it is. There's a little bit of a fun fact, a little pin that goes onto the map, and then learners go on to their next question where they're again able to look at a hint to make an educated guess. Now, sure, they can make I guess this is one place or the other, but making an educated guess just helps perhaps build again some background knowledge, some geography, and allows them to perhaps get their answer correct on the first try. And like I mentioned, learners can actually earn a badge. They can personalize their badge with their name if they wish, and they can also see their score out of 100%, how many answers did they get correct on their first try. And that badging aspect works the same way with both Where in the World interactives. We have 2 online right now, as well as with the classifying moon rocks. So again, if you don't want to do that in an online version with some of your learners, we have a printable version where you can print out an 8.5 by 11 sheet, cut it up into the picture piece, the name of the location and the little fun fact, and then the map showing where in the world that is, so that again, learners can say, oh, image number 1 goes with, that's Cape Cod, and that is map B. And they can kind of put those, match those together, again, reinforcing some of their knowledge. Plus the fact that they get to see some of these amazing views of Earth from space that get taken by astronauts orbiting around Earth on the International Space Station. So I thought I would mention that as well. And I will say, and this is a very eyesore kind of slide, but I will send in a follow-up email the links to all our resources that I've shared with you tonight. Some of them are draft resources so that they're not yet on our Aries website, but they'll be added soon. But they'll have all of the resources, the maps and poster size, the puzzle pieces, and all of that, all of the materials you would need for these resources. And I will send that out to you. The other thing I want to mention is we have some partners that have also created some very useful moon-related resources, like our NASA Eclipse partners. They've put together videos highlighting folks that work in the Lunar Lab. They highlight some of our lunar sample curation and new technology to study moon rocks. They have other resources that are available as well. And also our NASA Science Activation link, this science.nasa.gov/learn. Science Activation is a group of teams from around the country that work with formal educational environments, informal environments, museums, libraries. There are digital resources. There are so many different resources that are available and opportunities through our NASA Science Activation partners that I encourage you to check that out as well, because there are really powerful resources that might be useful for you there as well. So now with that is engage with NASA resources and activities, connecting space rock content and more with learning environments. Thank you so much for your participation. Thank you for Kim and Suzanne for their time and efforts as well in the Q&A and in the chat. And to all of you out there, the things that we create, we hope that they can be useful for your learning environments, and we hope that your learners can be inspired to be that next generation of NASA scientists, engineers, explorers, and so much more. So thank you so much for joining us. We very much appreciate you. Have a great night. Bye-bye, everyone.